All right, everyone, this is our chapter 16. We're starting a new chapter here with radian measure and circular functions. Today is an activity, our Smarties lab, to help us get ready for understanding this idea of measuring an angle in a little bit different way, called a radian. And then how do we convert back and forth between sort of our conventional system of degrees and what radians are. So that's what this is all about. So you need your Smarties circle, and you need your set of Smarties, and you will need a protractor to be able to complete the lab here, so the little activity. So we're going to start with just double checking and drawing in a radius on your Smartie circle. I've already used a compass to draw the circle with this radius, so we don't need to worry about step number 3, but I do need you to do the first 2. You're going to be pausing the video quite a bit to make these things happen, so I'm just going to have you kind of do them, or like pause the video, do the part of the activity, the directions, and then come back in when you're done with that. So the first direction is to place 7 Smarties in a row to form the radius of a circle. So we're just going to have you start at the center of the circle and do your 7 Smarties. Put a dot at the end just to make sure we can double check what that is. Draw on your radius to prove that your radius is in fact 7 Smarties, and you can even label it. So you can have your R equals here, 7 Smarties, so we can know our measurement system. So go ahead and pause and do that. All right, next up, just to sort of finish off, and I think this is helpful, once you've proven that it is in fact 7 Smarties, if you can go ahead and complete and go all the way out to do your diameter, use the straight edge of your protractor for that, or just a straight edge if you don't have a protractor handy, so you can see what that is. So if our radius was 7 Smarties, then that means our diameter would be how many? So the relationship between diameter and a radius, diameter is double, yeah, so that would be 14 Smarties across. So you don't have 14 Smarties, but we can calculate that just by knowing what the radius was. All right, so here's what we're going to do. We're going to understand what a radian is. A radian is where the radius of the circle is equal to the arc that you're traveling. An arc is just a piece of the distance around the edge of the circle. So we're going to start making arcs that are equal to the radius of the circle. So if the arc is going to equal the radius, that means I need to use 7 Smarties. So we're going to do a 7 Smartie arc along the edge of the circle to construct what we call 1 radian. So it comes from the word radius, right? So here's what I'm going to have you do. So you're going to place 7 Smarties along the edge of the circle. So you're doing these first red ones here. So these first red Smarties. So starting where your radius ends there, where you drew your radius in, and mark the spot at the end of that last 7 Smartie there. So what you are constructing there is 1 radian. I'm going to have you label it on your picture as well. So mark the end of it. Then I'm going to have you go ahead with your straight edge and draw that angle, draw that terminal side of your angle there, so we can actually measure what that is. So I'm going to have you pause the video, just do the first arc, pause the video, do that, and then I'm going to have you measure your angle that you think that is with your protractor. If you don't have a protractor, you can kind of guesstimate, but I want you to take a peek at what that is. So go ahead, pause the video. All right, so I want you to take a measurement here with your protractor. So again, pause the video with your protractor, measure what you think that angle measurement is, and come back. Hopefully what you got is something in the 50s. If you're doing this super duper well, and the picture is perfect, which we know it's ridiculously hard to make that happen. Oops, 1 radian is supposed to be in the upper 50s. So it's approximately between 57 and 58. It's actually about 57.3 degrees. So 1 radian is about 53.7. We'll talk more about why that is later. But for right now, just know that that's about where you should be. Okay, so now we're going to keep going. So I'm going to move my protractor. I want you to go ahead and do the next 7. So I want you to do 7 more. So we keep moving these Smarties. And again, mark the end and draw that ray in. So we have that next location. So that would be 2 radians, right? So if the first arc, each arc is 1 radian. So I'm going to have you do 7 more, mark it, and then 7 more. So the green, and mark it, and that's where I want you to stop for the moment. So do 2 more arcs. So again, pause the video, do 2 more arcs. So we'll have 2 radians, and then over to 3 radians. And again, please label as you go. So go ahead and pause the video and do those 2 arcs. Okay, now once you've gotten those 3 arcs done, I'm going to put in my diameter here. What you should notice is that you are short halfway around the circle. You didn't quite get there. I want you to guesstimate using your Smarties here. How many Smarties do you have to fill this gap? You should have a gap between your 3rd arc and the diameter of the circle. So the question is, how many Smarties? So take a second, pause the video, guesstimate what you think. It's a whole number amount of Smarties, by the way. Okay, so hopefully, if your picture is pretty accurate, you should have been 1 Smartie short. Your gap should have been 1 Smartie. So look at what you just calculated. Halfway around the circle is 3 complete arcs and then a little bit. So what number in mathematics are we using all the time that's just a little bit more than 3? Hoping you're thinking about pi. What you just calculated here is basically in radians what the measurement for pi is. So a little bit bigger than 3, halfway around the circle is considered pi radians. So when we look at that measurement where those arcs are coming from, that's half of the circle. So we're going to talk about that a lot more as we go around. But if we just have to kind of recognize, oh, look at that. That's 3 arcs and a little bit more. We're talking about circumference of a circle, like distance around the outside edge. Halfway around is pi radians. That's half of the circle. All right, so I want you to keep going. I want you to get all the way around now. So you're going to do 7 more and mark it. So again, that's starting from that one that you filled in for the gap. So you're going to do 7 more. 4, 5, 6, 7, mark it, 7 more, mark it, and keep going until you get all the way around the circle with your arcs. So go ahead and pause the video and do those arcs. All right, so as you completed a couple or 3 more here, let's go ahead and label them. So this would be 4 radians to here, and then the green would be 5 radians. That puts us just a little bit past 270 down there, and this would be 6 radians. So we're doing those 6 of those arcs that are equal to the radius of the circle, and then you should have a gap again. So hopefully you had a gap space for 2, kind of double check. So we had a little bit of a gap there because again, 3 more. Another halfway around the circle, so a little bit more than pi. We have that little gap over there. All right, so all the way around the circle is a little bit more than 6 radians. Okay, so if halfway around the circle was pi, then all the way around the circle would be double that, right? So that would be 2 pi radians would be the whole circle. So thinking about what you just calculated, that's the whole circle. So all the way around. Now the cool thing is then we're going to be able to figure out the conversions then between degrees and radians by understanding that what that measurement is in arc lengths, or those radian measures, those pi and 2 pi. All right, so let's think about what we calculated then. So what's the measure of each angle of the arc length of 7 Smarties? Just kind of discussion here. It's 57.3 degrees. Okay, the reason that is because halfway around the circle being pi in radians, right, 3.14, it's the same as 180 in degrees then, right? Halfway around the circle, 180. If you do 180 divided by pi, do that conversions, like how many degrees per radian. Just go ahead and type that in your calculator for a second. 180 divided by pi, you will get that 57.3 degrees. That's how many degrees there are per radian. So when we think about that conversion factor. So how many Smarties did we do in half of the circle? So think about what that would be. And the reason I'm doing this is for you to think about why we used what we did. So in each arc there were 7. So if we had 7, that would be 14, 21. Remember the gap was 1 more. So there were 22 in halfway around the circle. So the entire circle then would be double that, so 44 all the way around the circle, so that would be the whole circle. Now, why did we use 7 Smarties? Well, here's why. All the way around the circle, what is that called when we talk about the distance all the way around the circle? That's circumference, right? Circumference of a circle. So think about the formulas you know for circumference. Hopefully some of them come to mind, but pi times the diameter is probably the easiest. So think about what we know. We calculated all these. Our circumference is 44 Smarties. Our diameter was 14 Smarties. This would be a great way to get an approximation for pi. How would I do that? Well, I would just divide both sides here by 14. So that would give me, what, 44 over 14 in Smarties. But I can reduce that down to 22/7. In other words, kind of that simplified version, the halfway around the circle and then the radius numbers, right? Okay, well, think about this fraction. I'm going to say approximate. This is kind of our go-to approximation for pi. It's the closest thing we have with a rational number to get there, because remember, the actual number for pi doesn't stop, doesn't repeat. But 22/7 is our closest thing. So that's why I use 7 Smarties, so you'd be able to get that relationship. All right, so what are our big conclusions then? Well, we know we can go back and forth between using two different measurement systems now. We know that halfway around the circle is 180 in degrees, but it's pi in radians. We also know then that all the way around the circle in degrees, if you go all the way around, how far? Double 180 would be 360. That would be double pi, which would be 2 pi radians. So when we think about kind of our relationship here, that's how we're going to be able to convert and go back and forth. We can use our conversion factor. 180 degrees is equivalent to pi in radians, and we can use that to go back and forth. So that's really kind of where we're headed to be able to describe in two different measurement systems. So our conclusions here, our conversion formula, if you're wanting to go from radians to degrees, so we want a radian to degrees, so degrees for our answer, we're going to be multiplying by 180 over pi. So our conversion factor is 180 degrees over pi radians. So we convert, we multiply by pi over 1, or 180 over pi. Think of it, whatever you want your measurement system in, you're going to multiply by that on top, that conversion factor, just like we convert feet to inches, whatever else you're doing. All right, going the other way then, if you want to go degrees to radians, we're going to use the conversion factor then of 1 or pi over 180, because pi radians is equivalent to 180 degrees. So you're going to multiply by pi over 180. So we have the same conversion factor, where it just depends on which direction you're going. So we're either multiplying by 180 over pi or pi over 180. So for our first day kind of practice, we're going to be doing our conversion worksheet here to go from one to the other. They're going to have you fill out that information at the top. So how do you convert? And then you're going to be doing some of those examples. So for the first one, I'll just do one of each just to make sure. So to convert from degree measure into radian measure, we're going to multiply by, go ahead, pause the video and see if you can look back. You were going from degrees to radians. Remember, you want radian on top. Pause the video, write in what you're going to multiply by. Okay, so you should be multiplying by pi over 180. We want radians. All right, so for 60 degrees, we're going to multiply that by pi over 180. Now remember, if you have one thing that's a fraction, one that's not, super handy, rewrite it as a fraction. So you're doing 60 pi over 180. Now, a lot of people kind of freak out because they're like, oh my gosh, I can't do that arithmetic. But we should be able to break it down pretty easily. We're going to talk about lots of kind of shortcuts to make that happen, but for right now, let's just do what we can. So we can for sure divide by 10, so 6 pi over 18. Then we just have to reduce 6/18. So both of these are divisible by 6. So 6 divided by 6 is 1, so 1 pi. 18 divided by 6 is 3, so this would be pi over 3 radians. What we are looking for is an exact answer in terms of pi, so I want you just to reduce that fraction. All right, let's go one the other way, and then I'm going to turn you loose to finish up the rest. So to convert from radians into degrees, pause the video here and fill in the rest of this sentence. We're going to multiply by, pause and figure it out. We want degrees, so we're going to multiply by 180 over pi. So again, same conversion factor, halfway around the circles, pi radians. We're going to just do that multiplication. So we're going to multiply by 180 over pi. So I'll do the first one with you, and then I'll let you kind of work with the rest of them and see what you can come up with. The nice thing about these radian ones in terms of pi is the pi's do divide out. Now the tricky part is you're going to have 11 times 180 then divided by 6 left. So if we're thinking like mental arithmetic here, I would probably do the division first, because that's going to be a little bit easier to make that number smaller. If you're just using your calculator, I guess, great, go ahead, 11 times 180 divided by 6. But looking ahead into kind of shortcuts, it might be easier to think of it this way. 180 divided by 6. So mental math, think 18 divided by 6. 3, and then just add the 0 back on. So 180 divided by 6 is 30. So this is really 11 times 30. I know that seems kind of crazy to do, but that's not so bad. If you do 11 times 30, that ends up being 330 degrees. Don't forget your unit. Notice that degrees always have the degree symbol. Radians, they often just write the word radians, or they don't write anything at all. So when you see radian measures, like I wrote pi over 3, notice I didn't write radians afterwards. We just kind of assume if we don't see a degree symbol, it's in radians. So you don't have to write the word radians. We're going to assume that you mean that you're in radians. All right, so degrees to radians, radians to degrees. We're going from one unit of measure to the other for angles.